Okay, so our learning target today is hopefully by the end of this lesson, you'll be able to solve and write simple inequalities and represent your answers in multiple ways. So we're going to show you two different ways to display your answers when you get these. You should be able to solve these, and additionally, you should be able to write these using pretty simple language. All right. Okay, if you're just getting here, welcome. We are working on lesson 5.1 right now, and we're about to go to the first content slide. Okay, so we have this thing written down here. It says solve inequalities by addition. And it says an open sentence that contains less than, greater than, less than or equal than, or greater than or equal to is an inequality. The example above illustrates the addition properties of inequalities. I don't have the example listed, but the point of me putting this down is I want just really quickly to go over the fact that inequalities are actually almost more useful in many cases than an equation. Because if you look at a real life application, so supposing I say, okay, I'm going to give you $150 to do your back to school shopping. All right. And so you take your money and you go to the mall, and at that point you are working on an inequality. You are saying, okay, I have, $150 and I can spend less than or equal to that amount of money. And then, so supposing, you go and you get some shoes and you spend $70 on a new pair of shoes, and then you say, okay, I'm going to get a new pair of jeans, and those are $40. And then it's kind of like, okay, what's left? What else can I buy? Right there, you have just kind of put together an inequality. And what you guys would do in your head is you would just, subtract 70, get 80, and subtract 40 and get 40, and you say, oh, well, I have $40 left that I can spend. But that's algebraic thinking, and that's using an inequality. It's not using an equation. That is an inequality. So these are very useful, and we use them a lot more than we probably realize. So let's take a look at some formal use of this. So we have this inequality here, and it's going to take everything I have not to call them equations, just out of habit. So it says solve this, and so you've got this x minus 12 is greater than or equal to 8. Now remember, when you're reading it, okay, it's the side that is opened up is the larger side. It's always the larger side. The smaller side is the one that comes to a point. Okay, and I'm not going to use that silly analogy of, oh, the alligator is eating the big. That's just goofy. If you can just think that this is physically bigger than this little point here, you'll be fine, and you'll be able to remember it. Okay, when you have the line under it, this means or equal. That is what that line underneath it means. So you would say, you read it left to right. So if it's facing this way, how it is, it's greater than. And then if it's reading, it would be this is less than, and then whatever's over here. So that's our basic quick review of how to read these things. You don't do a lot of these in any of the 8th grade math stuff. You do in 7th. So you guys may have seen this last year, but I'm not sure how much. All right, so when you solve these, they're actually pretty straightforward. We're going to solve them like they are an equation, okay? So you think about what you would do if this were an equation. Well, what you would do is you would say, I got to get x by itself. Do the same thing for an inequality, and I'm going to do that by doing the opposite operation. So this says, oh, well, you're solving by adding. I want you to think more about solving by doing the opposite operation, all right? Because then you don't think, oh, well, I learned 2 things. You actually learned 1 thing. You solve by doing the opposite operation. So if you are subtracting from x, you're going to add. So you're going to add 12, right? And then that's going to give you x is greater than or equal to 20. Notice I kept the direction of the inequality sign going the same way. And then now I have my answer written as an inequality. And now what I'm going to do next, I'm going to show you how to write that on a number line. Okay, and we call this kind of graphing our inequality, right? So what I would do for this is I would just take kind of a random spot. I'd say, okay, we're gonna call this point 20, right? And we'll say 19, 18, 17, 16. Call this 15, right? And then 21, 22, 23, 24, right? So we'll just put a couple points there so we know what it is. And if you're going to do x is greater than or equal to 20, that means that all your values are going to be above 20, but including that point. So you always start by circling the number that is your answer, okay? And that's what I did. And then you will draw an arrow going in the direction of where your answers are. Well, your answers are saying that they're greater than that. So you would draw an arrow along this line, kind of just fatten it up, and then put an arrow there. And then the last thing you do is if you include this or equal, that means that's including the point. And if you're including the point, you bold it. If it was just greater than, you would leave it open. But if it's or equal to, you will include it. Okay? So that's probably almost more confusing and the harder thing to learn with this than doing the actual solving the inequality. Okay, so let's take a look at these two examples really quick. All right, and I'm going to do these a little quicker now that we've been introduced. So I'm going to go 22 is greater than m minus 8. All right, so I'm subtracting. So, and if you guys want to work on these on your own and then check and see how you do with me, that's absolutely fine. So we're going to add 8 to both sides because we're doing the opposite of what's being done. Again, I'm thinking about it in terms of opposite operation. So I'm going to add 8 to both sides. That gives you 30. And so you can read this one of two ways. You can read this as 30 is greater than m, or you can flip it around as long as you keep it meaning the same thing, or m is less than 30. And when you flip it the other way, you would turn the sign around. So you see that the small part is going towards the m. Well, it's still going towards the m here, so I didn't change that. So if m is less than 30, I could say we can make this 30 right here, okay? And then I'll put a circle around it. And then if it's less than 30, it's going to be all the values going this way towards negative infinity from 30, but not including 30. So I'm going to leave it open. So it stays open in this case because of the way the sign is. So the rule is if you have this or this, your dot stays open. If you have this or this, your dot is closed. Okay? And if you're not good with rules, then just think about it. Does it include the point or not? Well, this doesn't include the point. It says it's less than 30, but it does not include 30. So if it doesn't include the point, that means the circle's open. So it's everything right up to 30, but not including 30. All right, for 1b, same deal. D minus 14 is greater than or equal to negative 19. You're going to add because you're subtracting 14 from D. So we're going to do the opposite, and you're going to add 14. And then you're going to get D is equal to negative 5. All right, not equal. See, I'm saying it wrong. D is greater than or equal to negative 5. Okay, so I'm going to put negative 5 about right here. I'll go negative 4, negative 3, negative 2, negative 1. Put 0 right here just so I have kind of a reference of where we are. And then I would put my circle around negative 5, just like that. This is greater than, so I'm going to draw my lines going that way, put my arrow, and then now because I have this or equal to, that means it includes that point. So I'm going to fill it in. Any questions on these? All right. I'm watching the chat. Again, if you have questions, please feel free to put them in there. But I don't see anything right now. So let's move on. This is pretty straightforward. Today's lesson should be fairly straightforward for most of you. All right, now we're gonna do basically the same kind of thing, except you're gonna be subtracting. Now the reason that is because it's the opposite operation. If you have m plus 19, you are adding 19 to m, which means that your opposite operation would be subtracting 19. So you're always doing the opposite of what's being done to the variable. And then you just make sure you do the same thing to both sides, because linear inequalities also need to be balanced, just like equations. So we subtract 19 from this side, we got to do the same thing to the other side. And then you have m is greater than, what would this be? This would be 37? Yeah. Right? M is greater than 37. And then we would just take any random point on here. And because it's greater than, I'm going to put it a little more on this side of it. So 37, 38, 39. And then we'll make this 40. And then you put your circle around it. You draw your line going in the direction that your answers are going. And remember, the line goes, you read it, and that tells you m is greater than 37. The values of m that solve this are all greater than 37. And so that's why we're going this way like this. And then because it is not equal, it does not include this point, so we will keep it open. All right? I am recording this, so hopefully if you do miss something, you can get it written down. But in the interest of time, I do want to kind of get through this, so hopefully this is all making some sense to you guys. All right, let's look at another one using fractions. All right, so with this one, same exact approach. All right, I'm adding 3/4, so I'm going to subtract 3/4 from both sides. And then where this gets tricky is a lot of you hate doing fractions. So what we're going to do is we're going to take 1/3 and we're going to subtract 3/4 from it. We're going to write it out this way. Remember, what you got to do with these is you find your common denominator. Well, my common denominator is 12. That's the smallest number these both go into. Okay, so I have 12 minus something over 12. Now we're going to figure out what those somethings are. Well, 1/3, if you convert it into 12ths, right, you do that by multiplying 4 by your numerator and your denominator. And so that gives you 4/12. And then for 3/4, converting that into 12ths, you multiply both by 3. And so that gives you 9/12. So you have 4/12 minus 9/12, which 4 minus 9 is -5. That goes on top. And then you have your 12ths on the bottom. And so your answer is going to be k is greater than -5/12. And then I think the way I would do this one is I would say, okay, let's call this right here. How do we want to do this? Let's call this right here, we'll call this -1/2, which is -6/12. Or wait, actually, no, I'm being silly here. We will call this 0 right here. And then we'll say each one of these is a 12th. So this would be -1/12. This would be -2/12. And you guys get the idea. And then you would go to -5/12, which is right here. And then you would circle it. And because it's greater than, your arrow is going to go this way. And again, you are not going to include the point, so it will stay open. And so you can on your homework, they're going to give you number lines that have the numbers already on them, so it'll be a lot easier. But when you do get a blank one, it's not really that confusing. You just kind of want to put your values sort of like kind of centered to the left or right. All right, you still want to use as much of the number line as possible to represent this in a way that makes sense. Okay. Now, last kind of examples we're going to look at before we're going to look at writing these is when you have variables on each side, you do the same. You're going to do the same kind of thing. All right. The goal is, remember, that you want your variables together, and what you do with these is you move your variables over to the side that has more. And you're definitely going to want to do that with these because we haven't learned what to do when we have a negative coefficient yet and we're solving for that. Okay, so you're going to want to move the 3a rather than the 4a. So the 3a we're going to shift over to the other side so that we can get the variables all together. So we're doing the same kind of thing. We're still using the property of subtraction, right? Where you do the same thing to both sides by subtracting the same thing. But we're doing it with the variable. So then you get 6 is less than or equal to a. All right? So when I plot this, okay, I know I'm going to have the number 6 somewhere. So we'll put 6 right here, and then we'll go 5, 4, 3, 2, 1, 0, and that puts 0 right there. And so a is greater than or equal to 6. All right, I'm reading it right to left. A is greater than or equal to 6. You can read these either way. All right, most of us are more comfortable. Remember, you could rewrite it if you wanted to, provided that it's going in the same direction. So if a is greater than or equal to 6, you're going to put a dot around 6. You're going to fill it because it includes that point, and then all your values are going to go this way. So you're using the same exact approach that you've used in the past for these, for equations. The only difference is we have this graphing component now. Okay, so for these two, I'm just going to go through these quickly just to show you it's the same process. 9n over here, 10n over there, so that means that there's more on this side. So I'm going to subtract 9n from both sides. That's going to give me -1 is less than or equal to 9. Or n, not 9, n. All right, so I'll put -1 somewhere. Let's put it right there. And this means n is greater than -1. So you put your circle around -1 and you draw your line. Just like that. And then on this next one over here, it's the same thing. Which side has more? Well, 5 is bigger than 4. So we're going to move everything over to the 5h side by subtracting 4h. And you'll notice on all these when you do these that your coefficient is always going to wind up being 1. And that's because we haven't discussed multiplying or dividing yet, but that will be next. All right, so you have h is less than or equal to 12. So we'll put 12 on our number line. H is less than or equal to it, so we're going to put our circle around it, and then we're going to fill it in because it includes that point. And then my arrow is going to go to the left. All right, because it's all the values that are less than 12 that go up to 12 and include 12. All right, let's now shift gears just slightly and just think about how do we write these things. So they have a little chart in the packet that you guys can look at that kind of gives you phrases. So, you know, it says less than, fewer than. All right, fewer, you know, I can't really, I think you either get this or you don't. But if you look at these, this should at least give you kind of an idea of how it is. And I think that if all of you slow yourself down and think about it enough, that you'll be able to make some sense out of this. Right? Greater than, more than. All right. The ones that are tricky are the ones where they say at most, no more than, less than or equal to. So if you hear somebody say there's at most 20 people in my room, that means that 20 would be the top end. So you would have either 20 or fewer than that. So if you, like I said, if you think about it, no more than is the same way. If you think about it, these make sense. And then this last one is at least. Well, at least means that that's your lowest amount. Somebody says, how much money do you want to make for babysitting? You would say, well, I want to make at least $7 an hour. That means that if they offer you 6, that's not enough, right? It has to be $7 an hour or more. So that's where these come from. Okay, so let's just go over a couple examples. Define a variable, write an inequality, and solve each problem. Check your solution. All right, so with these, I'm going to concentrate more on writing them, and then I think with solving them and all of that, we'll let you do that. So I'll do that with this first one, but moving on, we're just going to write them. So it says twice a number is more than the sum of that number and 9. So twice the number would be 2x. Okay, so 2 times x, and I'm using x as my number, so I've defined my variable. Is more than, it's greater than the sum of that number. So sum means I have a addition of that number. Well, that number is x and 9. And you've written your inequality, right? Twice the number, that's this, is more than, that's that. And then the sum of that number and 9 is this whole works right over here. And then to solve this, you would just do what we've discussed. We'll subtract x from both sides. That gives you x is greater than 9. And then you would check your solution by putting 9 into this and say, well, is 2 times 9 greater? And when you check these, all right, you're going to get an equality on these. So the big thing is if you get an equality on this, this means it works. So another way to check this that I think is easier, all right, is if it says x is greater than 9, all right, pick a number that's bigger than 9 and put it in and see if it works. Well, let's pick 20. All right, 20 is larger than 9. So if you go 2 times 20, is that greater than 20 plus 9? Well, let's find out. 2 times 20 is 40, and then 20 plus 9 is 29. 40 is definitely greater than 29. And that's the easiest way to check these. Don't use the number you get for your solution because that's just going to give you an equality, and that doesn't really tell you anything. What tells you something is if you read and interpret what your answer is and then put in a value that falls in that range that's beyond that number that you get. Okay, let's look at a couple other quick examples of how to write these. The sum of twice a number and 5, all right, so sum means we're going to have adding. Twice a number is going to be 2x, so we got 2x, and 5. So the sum of twice a number and 5, so that's where your plus sign would be, is right there, is at most. So at most means that that's the biggest it's going to be, and it could include that. So that is less than or equal to. At most, 3 less than the number. Well, 3 less than means you're subtracting 3 from the number. So you have x minus 3. Now remember, it's not, there's a big difference between that and 3 minus x. This means 3 minus the number. If you say less than, remember that means that you're putting it on the other side of the variable. You're putting it to the right of it. So then to solve this, again, you move your variables over, all right? So this is going to give you x plus 5, and this one's a 2-step, all right? And now I want to get my variable by itself, so I'm going to subtract 5 from both sides. So a little more involved, but you guys know how to do this. We've solved equations like this, so solving an inequality like this is using the exact same procedures. All right, so x is less than or equal to -8. And so if you're going to check your answer for this, you would just put in any numbers. Let's use -10. So 2 times -10 plus 5 should be less than or equal to -10 minus 3. Well, on the right side, you get -13. On the left side, you have negative 20 plus 5, which is negative 15. And negative 15 is less than negative 13. You would only get it to be equal to it if you actually used this number. So I'm going to leave this there for you guys.